Anyway. Hey guys, MediaNutso here, and welcome to another edition of MediaNutso Streams. Well, for tonight, we've got another round of the Pokémon Learning Loop. Where we'll be covering a cornucopia, some math lessons. Oh, hold on, let me start. Now, before we get things started, I should preempt this by mentioning that today I haven't been feeling all that sporty. I came down with a rather bad head. And with a rather bad head earlier, which thankfully has gone good. But even still, I am still a bit iffy. And so for tonight, I'm only gonna stream for just an hour. Just to repeat, for tonight, I'm only gonna do an hour-long stream. But even though, then that doesn't mean we can't have a good time. So, with all that said and done, let's get the things going with our first math lesson.
That was a great combination, Pachirisu.
Yeah!
Pikachu! Chipper! Pachirisu? Pachirisu? Chipper! Oh, it's the smell of poffins. Oh, all right. I've got my brother's mixtures ready to go, and they're labeled with how many poffins he says they'll make. Now, if this batch makes 20 poffins, do I use the 4x5 pan, or 2 5x2 pans, or the 3x5 pan? Maybe that's it. Oh no! The poffin mixture overflowed! Oh, hi! Excuse us for interrupting. My name's Dawn, and this is Brock and Ash. My Pachirisu was drawn here by the scent of your poffins. Hi, I'm Keisha. Actually, that was the last of the poffins my big brother made. And if I can't figure out how to get the mixtures in the right pans, there aren't going to be any more poffins.
Wow! That's a lot of poffin mixture!
Yeah, we're getting ready for a big contest. So I cooked all this poffin mixture for all of our Pokémon, since poffins help boost Pokémon's performance in contests. The Pokémon all have different tastes, so he had to make a lot of different flavors. I want to surprise him by finishing up, but now look. I don't know which pans to use. My brother usually does this. He has so many different pans. Oh. We'll help you, Keisha. You will? Of course. I've had a lot of experience baking poffins with my mom. Pikachu! Thanks a lot. Please come in. Okay. The bowls of mixture are labeled with how many poffins each will make. See, this batch makes 20 poffins, so I put them in this pan. This is a 3x5 pan, so that makes 15. It does? It's like 5 plus 5 plus 5 equals 15. So, which pan makes 20? Well, this 2x10 pan does. This 4x5 pan does.
Or these 2 5x2 pans.
Well, which one is it? Oh, my brother's gonna be home soon.
You know, at times like these, it's a good idea to call Ada at the Learning League lab.
Pikachu! Hi, Ada! Hey, everyone! We're helping our new friend Keisha make poffins. This mixture will make 20 poffins. So we need a 20 poffin pan. So do we use this 2x10 pan? Or this 4x5 one?
Or these two 5x2 ones?
Any one of those would be correct.
What? Why?
Each of those arrangements equals 20. Let's start with the pan arrangement 4x5. It's really adding 5 4 times. 5 plus 5 plus 5 plus 5.
Equals 10, 15, 20.
Adding 5 4 times is the same as saying 4 times 5. In fact, you can look at each pan like a multiplication problem. You've got a 2x10 pan, or you could describe it as a 2 times 10 pan. 2 times 10 equals 20.
And my two pans are 5 times 2 equals 10, 5 times 2 equals 10, and 10 times 2 equals 20.
I guess that makes sense. There are different ways to come up with the same answer.
Exactly. When you multiply, different factors can give you the same answer, called the product.
I have a question. Does it matter if it's 4x5 or 5x4?
Nope. The order of the factors doesn't matter. Look at your poffin pan there. See, 4 rows of 5 equals 20. If you turn the pan, it still equals 20. It's just 5 times 4 now. We call these types of rectangular arrangements of things arrays. Sometimes you want to know the arrangement of things, not just the total. For instance, if you need to set up chairs on a stage for a band to play, you'd want to put the chairs in the correct arrangement to fit on the stage. So arrays help us figure these things out.
I think I get it. But I really don't want to waste any mixture.
Then let's go through a couple of examples to be sure.
That's a good idea.
Well, let's try the chairs on the stage I just mentioned. Say there are 18 band members, so you need to put 18 chairs on this stage. Which arrangement of chairs do you think will fit on this shaped stage? That's right! 2 times 9 equals 18. You have 2 rows of 9 chairs to equal 18. What about this stage? We need 18 chairs again, but this stage is big enough that you can have 2 different arrangements of chairs. Find 2 ways to set up 18 chairs. That's right. 3 times 6 and 6 times 3 both equal 18. We also see arrays in other places. How about this one? Let's say you are going to plant trees. You have these containers of little baby trees to plant. What can you tell about each container? They all equal... That's right! Each array contains factors that equal 24. So each container has 24 little trees. Let's say you're going to plant one of the containers. You have a large yard, but you want to make a path down the center so there is a row of trees on both sides. Which one of these containers is already the best array to line both sides of the path? Good job! The 2x12 container is already divided into 2 sections. All right! I think you're ready to do this on your own.
Thanks, Ada.
Well, let's try the
Let's help Keisha. Let's help Keisha to fill the correct poffin pans. Keisha and her brother will be very busy training, and between them, they have a lot of Pokémon who need poffins for the upcoming contest. Okay, which mixture will fill this 3x3 pan? Good job.
Oh, come in.
Which mixture will fill this 5x5 pan exactly? Click on the correct bowl. Awesome! Okay, this is a big one. We need a pan that can hold 36 poffins. Click on the correct pan. Awesome! Which pan holds 32 poffins? Try again. Good job. We need 3 different pans that can each hold 16 poffins. Click on the 3 pans and then click Check. Awesome! Looking for 12. Which 3 different pans each hold 12 poffins? Click on the 3 pans. Good job! Which combination of pans will hold exactly 24 poffins? Click on your answer. Great! What's that, Keisha? These are all the same flavor? Keisha says to mix the remaining mixture together because it's all the same flavor. So, we mix together batches that make 4, 6, and 10 poffins. That's 20 poffins total. Looks like we're back to our original problem. Choose the remaining combination of pans to make 20 poffins. Click on the pans you need to make 20 poffins and then click Check. Awesome! Good job!
Hey, what's going on here?
The puffins are done!
Wow!
I made a lot of poffins to prepare our Pokémon for the contest, and my new friends helped me.
That's awesome, sis. I'm sure they'll help our Pokémon do well at the contest. But we should give some to your friends for helping, don't you think?
I sure do! Thanks so much for helping. No problem.
Yeah, we wanted to help.
Giga!
And it looks like Pachirisu wants to help by being a puffin taste tester.
Pikachu!
Shh! I didn't say anything.
You're walking too loud.
Yeah, Heavyfoot.
We'll make a fortune selling these Pokémon supplies back to all those little twerps.
Look at all I've got.
That's not the way to carry that. Let me show you.
You're making a mess.
I've got some stuff. Oh, look out!
You're ruining everything. Someone's going to hear us. Just grab as much as you can and let's bolt.
Wow, what a disaster!
We're gonna have some unhappy customers. The superstore's due to open this afternoon. All of these boxes are filled with food and supplies by customer order number. We'll help. Pikachu! Oh, thank you. I must go find out who did this. Whoa, hold on. We can't just put boxes anywhere. They have to go up in order, or the superstore owner won't be able to find each customer's supplies.
Let's see. This one is number 215, and this is number 251. Uh-oh. These numbers are so alike. Which belongs in which spot? There are an awful lot of numbers here, and we need to work fast. Maybe Ada knows something that'll help.
Hey! What happened? A mess happened, and all the customers are coming for their orders this afternoon.
We're trying to put everything back into place by number, but we don't want to make any mistakes on the confusing ones.
Like these.
I see what you mean. Let's take a closer look at that 215 order. Look at the 5, the digit farthest to the right. The 5 is in the ones place. A digit is any of the numerals 0 to 9. A digit shows the place value in a number.
Numbers have places?
Absolutely. And to get the orders back in the correct spaces quickly, we'll need to understand place value. Think about the numbers 0 through 9. If you were typing or writing them, how many spaces would you need for each number?
1.
Right. So those numbers are called ones. Each is one digit. But we often need to count higher than 9, so what happens next?
We get to 10.
Right. And that's a 2-digit number. 10 is a group of 10 ones. Look at these numbers. The digit to the left shows how many groups of 10 are in the number. The digit on the left is the tens place.
What about all the zeros?
Those zeros are in the ones place, meaning that there aren't any ones, or values less than 10, in those numbers. Now look at this.
There's a 10 and a 5.
Right. Now what if you put those together?
You'd have 15?
Absolutely. And we'd write it with 1 in the tens place and 5 in the ones place. 15 means one set of 10 plus 5 ones.
But there's a third place in our number.
That would be hundreds, right?
Right. 100 is really just 10 groups of 10. Let's look at your first number.
Let's see. There's 2 hundreds, 1 10, and 5 ones. So it's 200 plus 10 plus 5. That's 215.
Now look at the other number.
I see 2 hundreds, 5 tens, and 1 1. 200 plus 50 plus 1. It's 251.
Now you can compare them. In place value, the lowest value is the ones.
That's the digit farthest to the right.
Uh-huh. The greatest value is the digit farthest to the left. Place value gets greater as you move to the left. Compare your two numbers. Start with the digits farthest to the left. Which is greater?
They're both 2s.
Right. They're both equal. Now move right to the next digit.
There's a 1 and a 5. The 5 is bigger.
You've got it. The number with the 5 is greater.
But what about the ones place?
Tens are greater than ones. When you compare numbers, always start at the far left. Compare each place value. If both are equal, move another place to the right. If one is greater, then that number is the larger number.
So with these two boxes, the 2s in the hundreds place are equal. The 2s in the tens place are equal, but the 7 in the ones place here is greater than the 3 in the ones place there. So 227 is greater than 223?
Right. But sometimes you'll need to count higher than that. There are thousands, 10,000s, and even 100,000s. Just remember that the number with the greatest place value is the digit farthest to the left. Let's break this number down. Start at the far right.
The 8 is in the ones place. Then the 7 is in the tens place. And the 4 is in the hundreds place. Oh, what's after that?
Think of it this way. Each place is 10 times the number of the place to its right. Tens are 10 times ones. Hundreds are 10 times tens. Thousands are 10 times hundreds. 10,000s are 10 times thousands. And 100,000s are 10 times 10,000s.
So the 5 is in the thousands place?
Right.
And the 3 is in the 10,000s place.
And the 6 is in the 100,000s place.
So we'd say this number is 635,478.
Thanks, Ada. Now let's start to clean this place up. It looks like some digits have fallen off the number labels of the boxes. Help us put the digits back into the right places. Click and drag the 8 into the 1.
That's it. Ones are the smallest part of a number. Their place is always the farthest to the right.
Click and drag the 4 into the hundreds place.
Great work. 100 is 10 groups of 10. Hundreds are greater than tens and ones.
Click and drag the 3 into the
Awesome. 1,000 is greater than 100. The greatest place value in a number is always the place farthest to the left.
Now click and drag the 9 in.
What do you call the place where you put the 9? Excellent. A 10 is one group of ones. It belongs to the left of the ones. Place values get greater as you move to the left.
Whew, look at this number label. Only a few digits have fallen off. Now let's try to get those back into place.
Super! 10,000 is 10 groups of 1,000. Place values get greater as you move to the left. 10,000 belongs next to 1,000.
Click and drag the 8 into the tens place.
That's right! Remember, tens are greater than ones. Tens belong to the left of the ones place.
Click and drag the 2 into the 100,000s place.
Fantastic! 100,000 is 10 groups of 10,000. That's a pretty big number, and the number with the greatest place value is always the number farthest to the left.
This number has no hundreds. Which of these answer choices would be...
Absolutely. When there is no value for a place, we put a 0 in that place.
It looks like... I'm glad we got that cleaned up. Now let's look at this area. Uh-oh. These boxes have to go back up on these shelves. But the boxes on each shelf are in order from greatest to least.
Click on the boxes that have fallen to the ground. Drag them into the right places on the shelves. Remember, compare the numbers to find the right spots for each box. Look at place value to tell which numbers are greater than others. Click on the boxes that have...
Awesome! Awesome! Nice work! Good job! Good job! Good job! All right! Awesome! Nice work! Nice work! Awesome! Good job! Oh no! This label is all mixed up! Look at the correct number in words below the mixed up number. Click and drag the digits into the right places. Awesome!
Look at this place now. It looks great. Thank you.
Now the store can open on time.
And now I'm exhausted. Let's go to the Pokémon Center to get some rest before the store opens.
Pika!
Oh, these boxes are so heavy. I can't take another step.
You shouldn't have taken things you couldn't carry, you knucklehead.
You said grab as much as you can.
Did I have to spell out that you'd also have to carry it? How? Oh no, look!
It's those twipes!
And Officer Jenny.
We gotta get out of here. Leave the stuff behind.
Look! Team Rocket!
Save yourselves!
They must have taken all this from the store.
You three are under arrest.
We'll have to take a rain check!
Pikachu, Thunderbolt!
We're blasting again!
Good job, Pikachu. With another Team Rocket plan foiled, everything is definitely in place. Pika! What do you think is going on?
Let's find out.
Pikachu! Officer Jenny, what's going on?
That trainer is a talented artist.
He's painting a mural as part of the Beautify the City campaign. He's known for counting his brushstrokes when he paints. Ooh! Ah! And look, his Smeargle is helping.
Cool! Smeargle is the painter Pokémon.
Viga, Viga!
Okay, next.
Oh, look! It's a pattern!
Yeah! Baneri, Starly, Baneri, Starly.
Oh no, my sketch! Smeargle? That's okay, Smeargle. I can fix it. I just wanted to get this done in time.
We can help you.
Yeah! What do we need to do?
Well, if you could fill in these patterns.
That's the mural?
This is just a sketch. I like to plan everything out beforehand.
Uh-huh.
Don't you just paint a bunch of leaves on the trees?
Well, I like to paint each tree with a certain number of brush strokes, and each bush, and the Pokémon here, see? So, if you can complete these patterns, I can go back to painting the rest of the mural. Together, we'll be able to get it done in a jiffy.
You got it.
Thanks a million.
Wow, he's really precise.
We gotta help him finish the mural. But these patterns are confusing, and he's really a perfectionist. Let's call Ada on the Poképilot.
What was I thinking when I bought this?
Hi, Ada.
Nice shirt.
Oh, hi there. I'm just getting some clothes together to give to charity. I don't know if anyone would want this one.
Well, that's quite a pattern.
It certainly is.
Which is why we called you. We're helping this artist finish his mural.
He's really picky about the number of brushstrokes he uses.
And some paint got spilled on his sketch, so we're going to help him fill in the missing numbers.
Interesting. So what do you want to know?
Well, he said this is a pattern. I guess it has something to do with the number of leaves?
That's right. Patterns can be things or numbers of things. Look at the colors in this shirt, for example.
They alternate. It's got 2 orange circles, then 1 purple circle.
That's right. A predictable pattern. And here?
1 purple, 1 orange, 1 green, then 2 of each, then 4 of each, then 8 of each.
Right. Patterns help you understand the relationships between things. Especially numbers, like the ones your artist friend has there. Those patterns involve adding or subtracting, or even multiplying and dividing.
Oh man, we have to get this done in time.
No need to worry. Ada, can you explain how to figure these patterns out?
Sure. Here, look at these numbers. Can you tell what comes next?
That's easy. 2, 4, 6, 8, 10, 12, 14.
Yeah, it's just counting by 2s.
It is, but how did you know what came next?
Well, you can see that the numbers were getting bigger.
Exactly. First, you look at whether the numbers are increasing or getting bigger, or decreasing or getting smaller. If the numbers are getting bigger, then you know you need to add or multiply.
Like there, we added 2 each time.
Right. 2 plus 2 equals 4. 4 plus 2 equals 6. 6 plus 2 equals 8, and so on.
So if the numbers get smaller or decrease, then you would subtract?
Yep. For a decreasing pattern, you want to subtract or divide. Look at this example.
It's a decreasing pattern, so we probably subtract.
Right. Now to figure out how much to subtract, you need to look at the relationship between the numbers you have.
Well, you subtract 5 from 30 to get 25.
And you subtract 5 from 15 to get 10.
So we're subtracting by 5 each time, like counting down by 5s.
It's like figuring out a code.
Ada, counting by 2s or 5s is easy, but some of these number patterns aren't so obvious.
Right. Not all patterns are simple, but they're fun to figure out. Why don't we go through a couple more examples together?
Good idea.
pattern here. Click the images to highlight the basic pattern and then click Check when you're finished. Correct! 2 red stars and 3 blue hearts is the basic pattern. Now, drag the shapes to complete the rest of the pattern. Right! Look at this number pattern. Is it increasing or decreasing? Good job! The numbers are getting bigger. Now, look. Right! We're adding 4 to each number. Drag the numbers to complete the rest of the pattern. Excellent! You add 4 to the number. Excellent! You add 4 to the number. Right! Look at this number pattern. Is it? Good job! Now, how much is it decreasing by each time? Good job! This pattern is subtracting by 9. Drag the numbers to complete the rest of the pattern. Excellent work! Excellent work! Let's try this one. It's tricky. Is it increasing or decreasing? Good job! The numbers are getting bigger. Now look at the relationship between the numbers. You got it! For this pattern, we multiply each number by 2. Now, drag the numbers to... Good job! I think you've got it.
Thanks, Ada.
Yeah, thanks, Ada. See you.
Adios!
Look at these vermi in groups of 3. Look at these wormhole. Can you complete the pattern? Look at these vermi in groups of 3. Can you complete the pattern? Good job! Awesome! Good job! Good job! Good job! Awesome! Look at these wormhole. Can you complete the pattern? Awesome! Now look at these groups of starly. 5, 10, 15. Can you complete the pattern? Great! Comby loved the sweet honey on the tree. Can you complete the pattern? Awesome! Here we have to fill in every other number of Cherubi. Can you complete the pattern? Good job! And the last one, this huge amount of leaves on the tree. Can you complete the pattern? Awesome! Awesome! We did it!
Did I hear that you're done?
Yes, here you go.
Excellent. Thank you so much. Now, watch this. Smeargle ready?
Smeargle!
Let's go!
Ooh!
Ah! Yay!
Wow, that's amazing!
Yeah, it's beautiful.
Thank you.
Smeargle!
Who knew there were 12 leaves in that section of the tree?
Well, now we do. Pikachu! Look at these vermi in groups of 3. Look at these wormpole. Can you complete the pattern?
Look at the fraction.
Look at the buckets and
It sure is quiet around here. Where is everybody?
You'd think people would be out enjoying this beautiful day. Munchlax, what is it?
Look, there's a whole bunch of people out there.
Oh, look! There's a berry harvest festival!
Let's go check it out.
There's Officer Jenny!
Let's ask her about the festival.
Hi, isn't it a lovely day for our berry festival?
Sure is! What's a berry festival?
Every year the people in this area plant berries, and then a few months later they all gather together and have a berry picking festival. Would you like to join in?
Sure, looks like fun.
Pick up some buckets over there and start anywhere you want. There are all different kinds of berries. Pick your favorites. You can keep what you pick. Just let me know how many buckets of each berry you pick so I can record it.
All right, let's go.
Here's one for you, Ash, one for you, Brock, and one for me, and... All right, Pikachu, here's one for you, too.
You too, Munchlax. But I hope you plan to really pick berries and not just eat them.
Phew, we've been working a while. Should we see how much we have of the different kinds of berries?
Let's see. I have 3/4 of a bucket of lumberries.
Oh, I have lumberries too. I also have 3/4 of a bucket. Brock, do you have any lumberries?
No, I didn't spend a lot of time over there. I only have 1/4 of a bucket of lumberries.
I wonder if Munchlax and Pikachu have any.
Guess not. So how much do we all have together?
Oh, I can add these fractions since the denominator, the bottom part, are all 4s. So we just need to add the numerators, or top parts. So that's 3 plus 3 plus 1 to make 7.
7/4? That's weird.
The denominator 4 is the total number of parts. So how can there be more, 7, than the total number of parts?
That doesn't make sense.
Yeah, it doesn't.
Okay. Any ideas?
Let's ask someone who really knows what's going on with fractions. Ada!
Hi, everyone. Oh, looks like a gorgeous day.
It is. We picked all these berries at the berry festival today, and we need to find out how much we have of each kind. But when we add up our buckets for the first kind of berry, we get 7/4. That doesn't make sense, does it?
How can we have more than the total number of parts?
It's not as weird as you might think. You just have an improper fraction.
Improper? Isn't that bad?
It just means they're different from proper fractions, where the numerator is smaller than the denominator.
Okay, but how do we figure out how much 7/4 means?
Let's take a look. As you said, the 4 in the denominator means the total number of parts in this fraction. 4 parts make up 1 whole bucket. So what does it mean if you have a numerator that is more than 4?
You have 1 whole bucket, plus a few more parts.
See? In this case, since your numerator is 7, and 7 minus 4 is 3, then that means you have 1 whole bucket plus 3/4 of a bucket.
Oh, I get it. 1 3/4 buckets.
Now that's another type of fraction. It's called a mixed number.
What's mixed about it?
A mixed number means that there is a whole number, in this case 1, and a fraction. That's our 3/4. So like Ash said, it's 1 3/4.
Hey, I'm pretty good at this fraction stuff.
Sounds like it. Now, do you want to see how easy it is to turn 7/4 into 1 3/4?
Okay.
First, divide the denominator 4 into the numerator 7. 4 only goes into 7 once, so you get 1. That's your whole number. But you also have a remainder of 3. You put the remainder 3 over the denominator 4 to make the fraction part of the mixed number.
That is easy. Hey!
Hey, those are wiki berries. Let's see how much we have.
I have a whole bucket of wiki berries.
I have a whole bucket too.
And I have 2/3 of a bucket. So it's easy to see that mixed number. 2 2/3.
Right.
Hey, if you can change an improper fraction to a mixed number, can you change a mixed number to an improper fraction?
Sure. First, multiply the denominator and the whole number. That's 2 times 3, which equals 6. Now add the numerator to the 6. That's 6 plus 2, which is 8. That's your new numerator. Your improper fraction is 8/3.
Let's try some improper fractions and mixed numbers so we can really figure out how many buckets of berries we have.
Look at the buckets and add them up to find an improper fraction. Make your fraction by dragging numbers from the number row into place. Put the numerator above the bar. Put the denominator below the bar. Make 2-digit numbers by dragging each digit from the row into its place. Then click Check. Awesome! To find the improper fraction, you add up the numerators and put them over the denominator that they all share. You know it's an improper fraction because the numerator is bigger than the denominator. Now that you have the improper fraction, can you change it into a mixed number? Make your mixed number. Great job! To get a mixed number, divide the denominator into the numerator to get the whole number, and use the remainder as the numerator in the mixed number. Look at the buckets. Then drag numbers from the number row into place to make the improper fraction. Then you've got it! Adding 2, 4, and 3 gives you the improper fraction 9/5. Now let's turn that improper fraction into a mixed number. Excelente! The mixed number comes from multiplying the whole number and the denominator and using the remainder as the new numerator. Now look at these buckets. Drag the numbers from the number row into place to find the mixed number. Excellent! A mixed number includes a whole number and a fraction. Now let's turn that mixed number into an improper fraction. Drag the numbers from the number row into place to make the improper fraction. Great! To find the improper fraction, just multiply the denominator and whole number, then add that number to the first numerator to get the new numerator. Drag the numbers from the number row into place to make the mixed number. Excellent! A mixed number includes a whole number and a fraction. Let's turn this mixed number into an improper fraction. Drag the numbers into place to make the improper. You've got it! Multiplying the whole number and denominator, then adding the numerator will give you the improper fraction's new numerator. Wow, nice going!
Thanks, Ada. Now let's get back to picking berries. We want to fill up more buckets. Come on and help. Look at the fractions as they appear. Turn any mixed numbers into improper fractions. Turn any improper fractions into mixed numbers. For every correct answer, you'll get some berries in your bucket. Try to fill it up. Drag numbers from the number row into place to make the mixed number. All right! Drag numbers from the number row into place to make the mixed number. Awesome! Drag numbers from the number row into place to make the improper fraction. Yeah! Drag numbers from the number row into place to make the improper fraction. All right! Drag numbers from the number row into place to make the mixed number. You got it! Drag numbers from the number row into place to make the improper fraction. Awesome! Drag numbers from the number row into place to make the improper fraction. All right! Drag numbers from the number row into place to make the mixed number. You got it! Drag numbers from the number row into place to make the mixed number. Yeah! Drag numbers from the number row into place to make the improper fraction. Awesome!
Wow! Thanks, Ada! Now we can figure out how many buckets of berries we have and tell Officer Jenny.
Look, behind you!
What?
Murkrow!
Murkrow? There goes the Pomeg berries.
Pikachu!
Yay!
Don't worry, we'll replace them.
I guess we better get started. See you soon, Ada!
Adios! Good luck!
Now listen up. You two guard these while we pick more berries, okay?
Pikachu! 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 Pikachu!
And don't eat all of those!
My snakes!
Pikachu!
I was going to buy 5.
What a mess!
Wow, what happened?
Some young Pokémon got loose in here. It appears they had a bit of a snack and made a bit of a mess.
That sounds familiar, doesn't it, Piplup? Piplup?
With my assistants out for the day, I suppose I should clean up this mess. It's important that we keep a careful count of all the Pokémon food.
Professor Rowan! Immediate assistance needed in Lab B!
I'll be right there! This mess will have to wait till later.
I can help, Professor Rowan. Piplup, Piplup.
That would be most appreciated, young lady. Here.
Okay.
The amount that we had is written on the sheet. I've already noted the amounts that are left. So you just need to multiply the original amount of each kind of food by what's left. See? Those 3 jars were full, but now each only has half left. So you multiply 3 times 1/2. Understood?
Sure.
Thank you very much, Dawn.
Let's see. Piplup? Now, why would Professor Rowan tell me to multiply when there's less food left? Don't you get more when you multiply? Pip? I'd hate to...
Yes. Yes, come in.
Tech support.
What is it?
Your clientele in living room needs your tech support.
Sorry about that. Had to help out with another game. Anyways, back to the action.
To mess this up, I know. I'll call Ada.
Hi, Don. What are you up to?
Hi, Ada. I'm at Professor Rowan's lab. There's a bit of a mess, so I'm helping by figuring out how much Pokémon food is left. Professor Rowan said to multiply the original amounts by what's left. Like this one, he said multiply 3 jars times 1/2, because that's how much is left. But I thought multiplying gave you more.
You bring up a good point. Usually, multiplying does give you more. But in this case, you're multiplying a whole number by a fraction. And a fraction is less than a whole number. It's part of a number, so really, it's like you're dividing. Think of multiplying by fractions as taking a part of something.
Oh, I see. My 3 jars aren't being increased by half. I'm taking half of each of them.
Exactly.
So 1/2 of 3.
Hold on. It also helps to write the whole number 3 as a fraction. And then you just multiply across, unless you can reduce the fractions by canceling first.
Let's see. First multiply the numerators. 3 times 1 equals 3. Then multiply the denominators. 1 times 2 equals 2. The answer is 3/2.
Yep. And now reduce the answer further by making a mixed number, 1 1/2. Actually, I'm multiplying fractions too. I'm making cookies.
Yum! But what do they have to do with fractions?
I didn't have enough flour, so I'm reducing the recipe by a third. How would I multiply a mixed number by a fraction?
What's the number?
2½ cups times 1/3, or 1/3 of 2½ cups.
Multiply 1/2 by 1/3, and then multiply it all by 2?
Not quite. First you need to change the mixed number 2 1/2 into an improper fraction.
I know how to do that. 2 times 2 plus 1 equals 5/2.
Exactly. Now, check. Can you cancel anywhere and reduce the fractions?
No.
Okay, then multiply the numerators across the top.
5 times 1 equals 5.
And multiply the denominators across the bottom.
2 times 3 equals 6. The answer is 5/6.
And always check if your answer can be reduced further.
Nope.
Great work! Want to try another for me?
Sure.
This time we're multiplying 2 fractions. The recipe calls for 1/4 cup of brown sugar, but I'm making a third of a recipe. So how much do I need?
I can't reduce the numbers any further, so I multiply across the top and across the bottom. 1 times 1 equals 1. 4 times 3 equals 12. 1/12? That seems so small.
Well, it can't be reduced any further, so 1/12 it is. Think you'll be able to figure out the amounts in the lab?
I think so.
Why don't we go over a few more problems while these cookies bake? There are a lot of other uses for multiplying by fractions.
Great. I want to make sure I've got it.
I was going to bike 5 miles, but I only made it a third of the way before I got a flat tire. How far did I bike? Sometimes it helps to visualize the answer before you do the math. Click and drag to show 1/3 of my total miles. That's right. What is 1/3 of 5 miles? That's right. 5/3 is 1 2/3. I'm making a half recipe, so I only need 1/2 of the 3½ cups of flour. Click and drag to show 1/2 of 3½ cups of flour. Stop when you get to the correct equation. That's right. What is 1/2 of 3½ cups of flour? Choose the correct. Excellent. Do you see how 1 3/4 equals half of the total amount now? There is half a pizza left and I want to give 3/4 of it to my friends. Click and drag the arrow to show 3/4 of 1/2 of a pizza. We're looking for 3/4 of a half. That's right. That's 3/4 of 1/2 of a pizza. What is 3/4 of 1/2 of a pizza? Excellent. Notice how the answer is less when you multiply by a fraction. I played basketball the other day. I usually make 6 out of 8 free throws, but this time I only made 1/3 of that amount. Click and drag to show 1/3 of 6/8. That's right. That shows 1/3 of 6/8. What is 1/3 of 6/8? Choose the correct answer. Good work! 1/3 of 6/8 is 6/24, or 1/4. The cookies are done!
Okay, so it's time for me to figure out these problems now. Thanks for your help, Ada.
Anytime!
You may want to get a paper and pencil to work these out with me. Choose the correct answer. Don't forget to cancel. Those 4 jars were full, but now they're 3/4 full. 3/4 of 4 equals... Good job! Those 12 small jars were full, but now I need to find 2/3 of that amount. 2/3 of 12 equals... Try again. Nice work! Next we have 5½ boxes of food, but half of each has been eaten. Nice work! And there were 7½ boxes of this kind of food, but now there is only 1/3 of each. Great! There was 3/5 of a bag of this Pokémon food, but 1/4 is left. What's 1/4 of 3/5? Awesome! Okay, one more. Here we had 1/3 bag full of Pokémon food, but 1/2 has been spilled. Good job! Great! We did it! Hey! Don't eat that!
Have you seen any Pokémon?
They went that way. Let's see. Now there's 1/3 of 1.5 left. 1.5 times 1/3 equals 1.5 is 3/2. Cancel the 3's. Half a jar is left.
I missed them. Have you finished the recount, Dawn?
I did. Here it is.
Good job. I knew I could count on you.
Thanks, Professor Rowan.
About that recount, perhaps you could stand by a little longer?
You know, I'm actually feeling much better than I was earlier. So you know what? I'm gonna do just a couple more.
Well, I think... Okay.
I'm so excited to see all the wild Pokémon at the preserve.
Yeah, I heard there were wild Zatu, Wooper, Girafarig, and even other Pikachu. Pika?
Huh?
Oh no, it's closed. Pika!
Oh, we came all this way. Officer Jenny!
Hi, everyone. I'm so sorry, but the preserve is temporarily closed.
Pikachu.
We hope to see some wild Pokémon in their natural habitat. How come it's closed?
The Pokémon population here has decreased, so Solana is coming to investigate. I'm gathering data for her on how many of each type of Pokémon are living in the habitat compared to last year's data.
Do you need any help?
Yeah, we're already here.
And we'd love to pitch in.
And I love you, Officer Jenny!
Anyway, can we help?
I could use some help figuring out how many of each type of Pokémon have migrated away from the preserve. Here's a copy of the official list of Pokémon living here last year. Will you figure out how many of each kind left the preserve?
Definitely.
Pika!
Great. I'll be on patrol. Let me know when you've got the data. Thank you.
Okay, why don't we split up the list? We'll each count a different type of Pokémon.
Sounds like a plan to me.
And then meet back here when you're done.
Great.
Pika-pee! Hoopa!
Wow, look at all those Wooper. Let's count carefully to find out how many are here total. There's 1, 2, 3, 4, 5... I counted 25 Wooper total, Pikachu.
Pika!
So now we just have to subtract that from the number of Wooper on last year's chart. That way we'll know how many we have left on the preserve.
Hoopa!
Okay, it says here there were 33 Wooper last year. And now there are 25 Wooper. But by what number did the number of Wooper decrease exactly? Since last year's number is larger than this year's number, I'd write that up as 33 minus 25. Okay, so first, well, I guess I just subtract the smaller number from the larger number?
Pika!
Okay, so 5 minus 3 is 2, and then 3 minus 2 is 1. That means 12 Wooper migrated or evolved.
Pika-pee!
Wait, that can't be right. There's less than 12 between 33 and 25. Weird. I wonder what I did wrong there. I guess if I knew what I was doing wrong, I wouldn't do it. This job is harder than I thought.
Pikachu!
Yeah, I'll get Ada to give my math a look-see.
Hola, Ash.
Hi, Ada. I'm here at the Pokémon Preserve. I have to subtract the number of Pokémon here this year from the number here last year.
Cool. It's important to preserve natural habitats.
Yeah, that's why it's so important to find out if too many Pokémon are leaving.
So true. So how's the counting coming?
Fine. It's my subtraction skills that are shaky. I mean, I know how to subtract, but something's off.
Then let's shake subtraction out.
Okay, well I counted 25 Whooper. But last year there were even more, 33. But when I subtracted, I couldn't take 5 out of the 3, so I got 12 as my final answer. That can't be right.
Well, you're thinking about whether or not your answer makes sense. Ash, that's a smart way to approach it.
Aw, shucks.
So what sounded off about it?
35 is 10 more than 25. And since 33 is less than 35, the answer couldn't be 12. It should be less than 10.
That's step 1. Now let's look at this problem together. This time, we're gonna trade up.
Trade up?
Yeah. Trading up is when you take one number and trade it up for 2 numbers.
How do you do that?
Let's say there are 51 of a certain type of Pokémon.
Pikachu!
Pikachu!
Let's say there are 51 Pikachu. How can I break the number 51 up so the tens will end in 0 and the ones column will have at least 10? You add 10 to the number in the ones column. In this case, I'm adding 10 to 1, so I get 11. Now, 11 plus what equals 51?
40 plus 11 equals 51.
Exactly. So now that I've traded up, I can subtract anything because I have more ones in the ones column than any other number could have. It's undefeatable.
Like Pikachu.
Pikachu!
Yeah.
So now let's look at your problem.
33 minus 25.
What can we do to solve that subtraction problem?
Trade up.
You said it. Now let's do it.
Okay. So first, I look at the 33, and I think, how can I break this number up so the tens column ends in 0, and the ones column is at least 10? Well, 20 plus 13 equals 33. Then I break up 25 into 20 and 5.
Sweet. You just traded up. Now that the tens and ones are split up, you can start subtracting.
Awesome! I'll start with the ones column. 13 is big enough to subtract 5, so 13 minus 5 is 8.
8, that's right. So now the ones column is subtracted.
Now it's time to subtract the tens column. I take the leftover 20 from 25 and 20 that I traded up for and subtract them.
And what did you get?
20 minus 20 is 0!
Yeah! So
13 minus 5 is 8. 33 minus 25 equals 8.
Ash, you rock!
Thanks, Ada.
But I want to take you higher with a 3-digit number. That's right, a number over 100.
Pikachu!
Let's say you have more than 100. Let's say you have 223 Whooper minus 147 Whooper. Our answer should be greater than 50, but less than 100.
Then it looks like we're going to have to trade up. I'm going to trade up 223 for 210 and 13. And I'll make 147, 140 plus 7.
Keep it up.
Yeah, and then start with the ones and subtract 13 minus 7, which equals 6.
Awesome. Now solve 210 minus 140.
It's got the same problem. The 10 is smaller than 40.
Yeah. So what you gonna do about it?
Trade up.
You got it. Now get to it.
Okay, so I'll trade up the 210 for 110 plus 100, because 100 is bigger than any other double-digit number. And there's already 10 there, so 100 plus 10 is 110.
Yeah, and?
Then I'll trade up the 140 for 100 plus 40. And since 11 minus 4 is 7, 110 minus 40 is 70.
Right. Now just subtract what's left.
So what I'm left with is 100 minus 100, which equals 0. So now I just have to add what I got when I subtracted the tens and ones columns, which is 70 plus 6. 76.
All right, Ash. You are a subtraction master.
Pikachu!
Well, I traded up.
And trading up makes change.
And sense.
Sounds like you're ready to go find those Pokémon.
Yeah, definitely. Let's start subtracting. Okay, now I'm gonna need your help subtracting the amount of Pokémon I counted from the numbers on last year's chart. Are you with me? Awesome, 'cause you're my best subtracting bud. Now let's subtract some Girafarig. But first, let's put our numbers on the chart. Can you drag and drop each number from 13 and 21 into the proper tens and ones section? Right, there are 2 tens and 21. Right, there is 1 10 in 13. Right, there is 1 1. Right, there are 3 ones in 13. Awesome! Will you break up the Girafarig and put them in the proper amount next to the numbers on the chart? Drag and drop the right amount of Girafarig into the tens and ones sections of each chart. Right, there are 20 Girafarig in the tens column of 21. Right, there are 10 Girafarig in the tens column of 13. Right, there is 1 Girafarig in the ones column of 21. Right, there are 3 Girafarig in the ones column of 13. Great! So now that we've done the breakup, let's trade up. What can I trade 21 up for? Right, 10 plus 11 equals 21, and 11 can subtract any number in the ones column. Now let's get down to the subtracting. What should I subtract first? Right, take your traded up ones column and subtract that first, because you can. Right, 11 minus 3 equals 8. Great, now tell me. Right, since we traded up the ones column, there are only 10 left from 21 to subtract with. So, it's 10 minus 10. Right, 21 minus 13 is 8. Awesome! You're getting really good at subtraction.
Yeah, you're practically subtracting pros.
Thanks! Well, I better get going to meet back up with Max, May, and Brock. Thanks for all your help, Ada.
Anytime, amigo. Adios.
Pika-pee!
And there they are. Good eyes, Pikachu.
Pika-Pikachu!
Hey, did you get your numbers?
Well, I just got counts of how many Pokémon are here at the preserve. Now, I need to subtract that from last year's number.
Me too.
Me 3!
Okay, now I'm gonna need your help subtracting the amount of Pokémon I counted from the... Well, I think we can help them. Match up the correct choice on the left with the right tile on the right. For each correct match, part of the picture of the preserve will be revealed. You may need a pencil and paper for this part, because we're about to do some serious subtracting. Are you ready? Then let's do it! Try again. Awesome! 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 All right! Awesome! Awesome! All right! All right! Awesome! We did it!
Hey, gang! How's the count going? You've got perfect timing. Here's the count we came up with. Whoa, you're good. So it seems a lot of Pokémon have decreased due to migration or evolution. This will definitely make Solana's job easier as she looks at what needs to be done to attract new Pokémon. Thanks for all your help.
No thanks necessary. Just letting us into the preserve to see all these great Pokémon was thanks enough, Officer Jenny.
Yeah!
He got you!
Tanks J and something's wrong with these new tanks. The tank workers sure left in a hurry. But he said we have to make sure the weight is spread evenly across the floor. Because he figured out how much the water weighs for each tank, I don't need to worry about that. I just fill them to the line. But I need to make sure I put the correct number of Pokémon in each tank according to their weight. The note he left said, after the tanks are filled to the line with water, Tank A holds a total of 16 pounds of Pokémon, and Tank B holds a total of 12 pounds of Pokémon. Each Barboach weighs 4 pounds. How many Barboach per tank? So I filled the tank to the water line, and then I wasn't sure. I just put more Barboach in Tank A because it was bigger. But I guess it's more specific than that. I'd better ask Ada for help. Hang on, we'll figure this out.
Hi there, Misty. What's new?
Hi, Ada. Well, actually, a bunch of tanks for the water-type Pokémon are new.
Well, that's good.
I guess, but the notes are confusing.
How so?
Well, like this tank for the Barboach keeps overflowing. I think I put too many in it.
I see that. Can I take a look at the directions?
Sure. I filled the tanks with water, then I wasn't sure what all the numbers meant, so I put more Barboach in Tank A, and look what happened!
We'll get this worked out. When you've got a word problem, there are a few steps you need to follow to solve it. First, let's read the entire problem and make sure we understand what it's asking for. What is this problem asking you to find?
The number of Barboach I should put in each tank?
That's right. Now you know what you're looking for. The next step is to identify the important facts, like numbers. It's helpful to underline the numbers you know, and sometimes you can draw a picture.
Well, there's Tank A and Tank B. And Tank A holds 16 pounds, and Tank B holds 12 pounds. And we know that Barboach weighs 4 pounds. Those are the facts, but how do I know what to do with them?
Great question, Misty. That brings us to step 3. In step 3, you look for the key words. Key words tell you what operation you need to perform, like if you need to add, subtract, multiply, or divide. Keywords like increased by, more than, sum, together, total tell you that you need to add. Keywords like decreased by, less than, minus, the difference between tell you to subtract. Keywords like multiplied by, the product of,
and increased by a factor of tell you to multiply. And keywords like percent, out of, ratio of, or quotient of tell you that you will divide. And you know that words like is, are, gives, or yields means equals.
I get it. It's like the keyword gives you the key to solve the problem.
Exactly. It unlocks the whole puzzle for you.
So, I know the total weight of Pokémon each tank holds, and I know how much one Barboach weighs. So, is the keyword per? As in, how many per tank?
That's right, Misty. Per is the keyword. It's a small word, but it's important. Keywords tell us what operation we need to perform. What do you think you need to do?
I think I need to divide the total weight by the weight of one Barboach to find the number of Barboach that will fit in the tank. So per means to divide.
Right. When you see the keyword per, you divide. Now you can write your equations and solve the problem.
Let's see. 16 divided by 4 equals 4. So there should be 4 Barboach in tank A. And 12 divided by 4 equals 3. So there should be 3 Barboach in tank B. There. That's better. Thanks, Ada. That was easy. The key word told me what to do. But look at all these other problems. How will I figure them out?
Practice. Why don't we go over some other keywords?
That's a great idea. Will you help me figure out what these other keywords mean?
Read the problem, then click on the key word. That's right! We're looking for the sum of 5 and 3. What does the keyword sum mean? Excellent! 5 love disc added to 3 Goldeen gives us the sum of 8 Pokémon. Click on the keywords. You found it! Increased by tells us what we will do with the numbers 27 pounds and 33 pounds. What operation should we perform when... Right! 27 pounds of Pokémon was increased by 33 pounds of Pokémon, and we add them to get 60 pounds of Pokémon. Click on the keyword. Keywords show the relationship between the two number facts. Try again. Good job. Less tells you what is different about the two numbers. What does the word less tell us to do? Correct. 7 horsey minus 4 horsey equals 3 horsey. Click on the key words. You did it! Difference between. What do you need to do to find... Right again! We subtract. 75 pounds minus 44 pounds equals 31 pounds. Polytoad weighs 31 pounds more than Poliwhirl. Click on the key word. Try again. Keywords tell you what to do with the numbers. Great! Times is the key word. What does times? Right! Times means we multiply. 4 love disc times 5 equals 20 love disc. Click on the key words. Excellent! Product of is the key word. Good job! We multiply to get a product. The product of 19 pounds and X number of love disc is 19 times X. And we don't know the answer unless we know what X stands for. Find the key words in this word problem. Good work! The ratio of tells us the relationship between the numbers. What do we do to find... Great! We divide.
To write a ratio, we can write it as 3 to 1, as in 3 star you to every 1 star me. When we see a ratio expressed this way, we know we divide the number of star you, we'll call that number x, by 3 to get the number of star me. We'll call that number y. Click on the key words. Very good! Out of describes the relationship between the numbers. What do we need to do? Good job! To find a number out of another number, we divide, and that gives us a percent. We'd write 7 out of 10 Poliwhirl have evolved into Politoed, or 7 divided by 10, which gives us 70%. So 70% of the Pokémon in the tank are now Politoed. You did it! Remember to look for keywords when you solve word problems.
Thanks for your help, Ada. I better figure out these problems and get the Pokémon in the right tanks.
No problem.
Now that we know some key words, can you help me with this challenge? Tanks J and K are the same size. Combined, they hold a total of 450 pounds of Pokémon. If a Politoed weighs 75 pounds, how many Politoed will fit per tank? We'll put you in your new tanks in just a minute.
Politoed.
What do we need to find? Awesome! Step 2. We need to identify all the important facts. Try again.
That's what I do.
Tanks J and K are the same size. Combined, they hold a total of 450 pounds of Pokémon. If a Politoed weighs 75 pounds, how many Politoed will fit per tank? We'll put you in your new tanks in just a minute.
Politoed.
Now, step 3. Click on the keywords in the problem. There are 2 keywords in this problem. Awesome! Step 2. We need to identify all the important facts. We can draw a picture too. Now, step 3. Click on the keywords in the problem. There are 2 keywords in this problem. Excellent! Step 4. Use the keywords to write our equations. Remember, we have 2 equations to write. Click on the correct pair of equations. We're almost done. How many Politoed will fit per tank? Click on the correct answer. Awesome! Thanks! You've been a big help.
Polydor.
Just one more challenge. Let's try it. Tank L can contain 6 Horsey, 8 Love Disc, and 1 Poliwag. If one Horsey weighs 18 pounds, and 1 Love Disc weighs 19 pounds, and 1 Poliwag weighs 27 pounds, then what is the combined weight of Pokémon that Tank L can hold? A lot of weight? Seriously, we can figure it out. What is the problem asking us to find? Great! Find the facts that we will use. Try again. Try again. Now find the key words. Try again. Awesome! Next, we use the key words to write the equation. Which equation will give us the total weight of each of the 3 types of Pokémon? Try again. Excellent. And our answer is... Great! Thanks for helping me with these problems. Using the keywords... What? Psyduck! The combined total Pokémon weight in the tank should be 287 pounds, not 287 pounds plus Psyduck. Tanks J and K... K are the same size. Combined, they hold a total of 450 pounds of Pokémon. If a Politoed weighs 75 pounds, how many Politoed will fit per tank? We'll put you in your new tanks in just a minute.
Politoed.
What do we need to find? Awesome! Step 2. We need to identify all the important facts. We can draw a picture, too. Now, step 3. Click on the keywords in the problem. There are 2 keywords in this problem. Excellent! Step 4. Use the keywords to write our equations. Remember, we have 2 equations to write. Click on the correct pair of equations. We're almost done. How many Politoed will fit per tank? Click on the correct answer. Awesome! Thanks! You've been a big help.
Politoed.
Just one more challenge. Let's try it. Tank L can contain 6 horsey, 8 love disc, and 1 polywag. If 1 horsey weighs 18 pounds, and 1 love disc weighs 19 pounds, and 1 polywag weighs 27 pounds, then what is the combined weight of Pokémon that Tank L can hold? A lot of weight? Seriously, we can figure it out. What is the problem asking us to find? Great! Find the facts that we will use. Try again. Excellent!
Can't believe we almost forgot that part.
Now find the key words. Awesome! Next, we use the key words to write the equation. Which equation will give us the total weight of each of the 3 types of Pokémon? Excellent! And our answer is... Great! Thanks for helping me with these problems. Using the keywords... What? Psyduck! The combined total Pokémon weight in the tank should be 287 pounds, not 287 pounds plus Psyduck. Tanks J and...
Okay, one more.
You may need some scratch paper to figure out these questions about volume.
Whoa! What's going on in this Pokémon Center?
Pika-pee, Piplup? Is it closing?
There's Nurse Joy!
Hello, everyone.
Hello, Nurse Joy. We saw all the boxes.
Hello, Nurse Joy! Your Chansey is as radiant as you are. You know, I have a baby Happiny that you might like to see. Happiny, come out and say hi!
Happiny!
What an adorable Happiny!
We were wondering, what's with all the boxes, Nurse Joy? The center isn't closing, is it?
Oh, goodness, no. We're getting supplies and food together for a small town that doesn't have a Pokémon Center.
That's a good cause. Is there anything we can do to help?
I'd love some help. Could you please bring me the largest boxes you can find from the storage room? I need the ones that can hold the most supplies.
No sweat. Don't worry, Nurse Joy. We'll help.
Happiny!
Why, thank you.
Chansey!
Coming! The storage room is just back that way.
No sweat. These boxes look so similar. Do you know how to find the ones that hold the most supplies?
Well, not exactly. But it's for Nurse Joy! Anyway, I think we can just look at the sides.
Okay, like the area of the side?
But wait, that's just for one side. That wouldn't be the space inside.
So how do we figure out the inside of the box, too?
Ada!
She'll know what to do.
Hi, everyone. What's up?
Nurse Joy is packing up supplies. She asked us to bring her the boxes that will hold the most, but these boxes look pretty similar.
We know about the area of a side of a box, but that's just one side. How do we figure out how much can go inside the whole box?
You're not too far off. Since you know how to find area, you're on your way to finding how much can go inside the box. It's volume.
So volume is what you fill up?
Look at it this way. The amount of space a solid object takes up, like a ball or brick or sugar cube, is its volume. When we're talking about filling something up, we're also talking about volume. It can be filling a hole with dirt, filling a glass with water to the top, or filling a box with Pokémon food.
Got it. So in all of those examples, the volume is how much it will hold.
So if we figure out the volume, then we can figure out how much stuff can go in there?
See? That doesn't sound so hard. No sweat.
Nope. Especially when you think of it like this. Volume is measured in cubic units. Think about those cubic units as little cubes. Maybe they're cubic centimeters, cubic meters, cubic inches, or cubic yards.
Oh, so those little cubes can go into the box, right?
You got it. Let's say they're cubic centimeters. All those little cubic centimeter cubes will fill up the box. When you can figure out how many there are, you can figure out the volume. Try it.
Looks like 12 cubic units.
Right on, Dawn. You get the idea. Now that you know what it looks like, to find the volume of a rectangular prism, all you need to know is its length, width, and height. For a rectangular prism, the formula for volume is length times width times height. Let's say this rectangular prism is 5 centimeters in length, 6 centimeters in width, and 10 centimeters in height.
Well, 5 times 6 is 30.
And then 30 times 10 is...
300?
Almost. Just remember that you need the cubic unit, so...
Oh, right! The volume of the rectangular prism is 300 cubic centimeters.
Excelente! Now to compare, let's look at this rectangular prism. Its dimensions are 15 centimeters in length, 10 centimeters in width, and 2 centimeters in height.
Okay. 15 times 10 is 150. And 150 times 2 is also 300. Its volume is 300 cubic centimeters too?
That's right. You can have a prism with different dimensions but the same volume.
I think we're ready to try this out. Will you help us? Whoa! What's going on?
You may need some scratch paper to figure out these questions about volume.
Look at these two shapes. Which one occupies more space?
You got it. The shapes are arranged differently, but they occupy the same amount of space.
Can you help me figure out how many cubic inches will fill up this small box? Try dragging and dropping them into the box shown. Then, click on your answer.
All right. You filled the box with 8 cubic inches.
What's the formula for finding the volume of a rectangular prism?
Bueno! To find the volume of a rectangular prism, you multiply the length times width times height.
I want to find the volume of this rectangular prism. It has a length of 10 inches, a width of 2 inches, and a height of 5 inches.
Right again! You multiplied the length by the width by the height to find its volume.
Try dragging and dropping the cubic meters into this large box. How many will fit?
Great job! You filled the box with 60 cubic meters.
What are the dimensions of the box? Let's look at the cubic units to find the answer.
Great! You found that it is 5 meters in length, 4 meters in width, and 3 meters in height.
If I need to put 80 cubic feet of supplies in a box, how many boxes will I need if each box has a length of 2 feet, a width of 5 feet, and a height of 4 feet?
Bueno! You multiplied the length by the width by the height to get 40 cubic feet. You need 2 boxes to hold 80 cubic feet of supplies. You may need some scratch paper to figure. I think we've got the hang of it. Can you help us figure out which boxes to use?
Look at all these boxes! Can you help us figure out which ones to use? You may need some scratch paper for your work. Ready? Go for it!
How many cubic feet fit in this box? You can drag and drop the cubes to fill up the box, then click on your answer.
All right!
So then what is the volume of this box? Click on your answer. Yeah! This box has a length of 2 feet, a width of 4 feet, and a height of 3 feet. What is the volume of this box?
Calculate the volume. Then place your answer on the label by dragging and dropping numbers from the number row. Click Check when you're done.
You got it!
I think we'll need some bigger boxes. This box has a length of 4 feet, a width of 3 feet, and a height of 5 feet. What is the
Awesome!
How about this one? This box has a length of 6 feet, a width of 3 feet, and a height of 3 feet. What is the volume of this box?
Calculate the volume. Then place your answer on the label by dragging and dropping numbers.
Yeah! Which one of these boxes is bigger? First, calculate the volume and fill in the labels. Yeah!
Awesome!
You got it! Click on the biggest box.
Good job! Great! We found the biggest box! Now, if we wanted to fit 158 cubic feet of supplies, how many boxes will we need?
Try again.
Awesome!
Okay, let's bring these boxes to Nurse Joy. She'll be so impressed.
Brock? Where exactly are you?
Looks like I boxed myself into a corner.
Why, what do we have here? Looks like you found some boxes for me, and a bit more.
Nurse Joy? Special delivery!
And I think that'll do it for this edition of MediaNutso Plays. Now, yes, I did stunt them on those last two. But hey, can't always get it right the first term. Right? So, anyways, tomorrow night we'll continue with another edition. where we won't once more go into the world of Humongous Center Toad. Only this time, it will be with the character that got it all started, Putt Putt. Until then, see you later.